All right, our objective today is that we're going to find the volume of an object created by rotating an area around a horizontal line. All these formulas typically end up being pi integral of a function squared, where that function represents the radius. So we're gonna see a lot of variation in exactly how this works, but just keep in mind that's always what we're doing. It's pi r squared, where the radius is the function value. In this first example, it asks for the volume created when this function, 2x squared, is revolved around the x-axis from 0 to 3. So we'll set this up as the integral from 0 to 3. And then it's pi radius squared, and our radius in this case is 2x squared dx. This is it. I know you can finish this. I'm not going to finish it for the purposes of this video, but that's the setup. So if you want to see what this looks like, this is what this graph would look like. 2x squared is a parabola that goes through 0, 0. X equals 0, and then 1, 2, 3. So it would look like this. And this area revolved around the x-axis would create kind of a wide cone. Sorry for my drawing here, but that would spin around and it would make this not quite a cone, more like a funnel, because it's not the sides aren't straight. But that's it. This function would give us the volume of that funnel. Next example is very similar, except it's revolving around a line that's farther away. So just remember, it's pi times the radius squared. I know this isn't the real notation here, but since the line y equals -4 is farther away than the x-axis was, our radius is going to increase by 4. So for our second example, it's going to be the integral from 0 to 3. We still have the pi out front, we always will for these, but our radius is now that 2x squared, but it's been increased by a value of 4, because -4 is 4 units farther away than the previous radius was when it was just going around the x-axis. So just for a quick drawing of what this would look like, still have this parabola that looks like that. But -4 is down here, so as this revolves, it would almost make like a volcano shape, where instead of coming to a point because it's rotating right there, it has this flat circular piece on the side. And again, you could solve this using whichever method you would use, but we're going to move on for the purposes of this video. Third example, it's going to be slightly more complicated still. We still have 2x squared, but now we have the area between 2x squared and a horizontal line revolving around that same line, y equals -4. So for the difference here, notice that this one, it was the full distance from this function to that line of rotation, which meant that it was a volcano that was completely filled in. This example, and I have to draw this again, is that function down to y equals -1, which is right here, revolving around y equals -4, which is right there, which means that this area is not going to completely fill in. There's going to be a hole in this. So this is going to spin around, and that side's going to spin around, and you can see my perfect drawing here. It's going to end up with this hole in the middle of kind of, again, a volcano shape. Because it's the area that's revolving doesn't touch the axis of rotation. So you notice each one of these builds a little bit from the one before it. Excuse me, it's from the last video. So that's the idea here. But the difference here is this. The function that we use, it's pi r squared, pi integral of r squared. But in this case, if you just look at that edge there, if I want to find that area, that's not one piece. That is a circle with a smaller circle subtracted. And the smaller circle and the larger circle are based on the radius distance from -4. So what we're going to do is this. It's going to be the integral from 0 to 3 still and we still have a pi out front. But because there's two circles, we're going to have the first circle squared, that bigger circle, subtracting the smaller circle squared, which is that circle that I haven't filled in red. The radius of the larger circle is that function 2x squared, and then plus 4, because it's 4 units away from the x-axis. The smaller circle that's being subtracted is -1, which is the y value of that bottom part of it, and then also plus 4, because it's 4 units closer. So that is going to become 3, which you can probably just count that radius was going to be 3, because it went from -1 to 4. Notice that this always will work out. If the value that you're revolving around is 4 units down, it's going to be plus 4 to both of those radii, and 2x squared and -1 were the original 2 radii that would go in the 2 circles before that 4 was added. You're going to need to do a lot of practice with these. You notice I haven't even integrated any of them, but the setup is what's the important part here. So our objective today was that we were creating volumes by rotating areas around horizontal lines, often the x-axis, but could be other horizontal lines.